Hi everyone. Today we're going to study applications of Laplace transform in solving differential equations. Let us study first Laplace transform of derivatives. Let f of t be the given function. Laplace transform of f prime of t equals s times Laplace transform of f of t minus f of 0. Next, Laplace transform of f double prime of t equals s squared times Laplace transform of f of t minus s times f of 0 minus f prime of 0. Third, Laplace transform of f triple prime of t equals s cubed times Laplace transform of f of t minus s squared times f of 0 minus s times f prime of 0 minus f double prime of 0. Example 1. Use the Laplace transform to solve the initial value problem. Y prime minus 2y equals e raised to 3t. Given y of 0 equals negative 5. First thing to do, take the Laplace transform for each side of the equation. This is our equation. We will show that Laplace transform of the left side equals Laplace transform of the right side. Then let us show that we're going to take Laplace transform for each of the terms of the left side. It becomes like this. Then let us evaluate this Laplace transform of y prime. A while ago, we have this formula. Laplace transform of f prime of t equals s times Laplace transform of f of t minus f of 0. Equivalently, for this Laplace transform of y prime, we will write s times L of y minus y of 0 minus, for this L of 2y, we will put the constant 2 in front of the Laplace transform. So we have this negative 2 times L of y equals, we just copy the right side value. Next step, this y of 0, we have a value that is given which is equal to negative 5. Let us substitute in here. Let us simplify further by doing like this. We can see that we put together all terms with L of y close to each other. This negative of negative 5 becomes plus 5. And the right side, we simplify now the Laplace transform as 1 over s minus 3. Next step, we're going to group the two terms with L of y. We will factor out that L of y value. So we have this quantity s minus 2 times the L of y equals this positive 5 we will transpose to the right. It becomes negative. Next step, we're going to combine this 1 over s minus 3 minus the whole number 5. Let us show that considering our s minus 3 in the denominator, we will multiply this 5 by the fraction s minus 3 over s minus 3. Let us simplify this right side and we will have this negative 5s plus 16 all over s minus 3. Next step, we're going to isolate this L of y on the left side. We're going to multiply this equation by the quantity 1 over s minus 2. And the resulting equation is now like this. L of y equals the negative 5s plus 16 all over the s minus 2 is now down here multiplied by s minus 3. We will simply take the Laplace inverse of both sides of the equation. So the value of y is equal to Laplace inverse of this fraction. At this point, we're going to solve by partial fractions. I'm going to put the link of the video regarding inverse Laplace transform by partial fractions in the description below. Let us copy this fraction down here, and this is now equal to a over s minus 2 plus b over s minus 3. Then let us solve for a and b respectively. We're going to multiply this equation by the LCD. Remember that the LCD here is the denominator of the fraction on the left side. By doing so, the new equation becomes like this. Now let us solve for a. Look at this variable b with a factor s minus 2. Let us eliminate b by setting s equals 2. Let us substitute the value 2 to all s in this equation. And then we will find that the value of a equals negative 6. Now let us solve for b. Look at this variable a with factor s minus 3. Let us set s to be equal to 3, meaning we're going to change all s by the value 3. So we can solve for the b. And the b here is equal to positive 1. Next thing, we're going to change the value of a and b in these fractions respectively. So it becomes like this now. Let us now rewrite the equation here using the partial fractions, so it becomes like this. And then let us show that we're going to take Laplace inverse of each of our fractions inside the grouping symbol. Let us simplify further by this negative 6 as numerator to be placed in front of Laplace inverse of 1 over s minus 2. And then we will now apply our formula for Laplace inverse transform. So the final answer is y equals negative 6 times e raised to 2t plus e raised to 3t. Example 2. Solve y double prime minus 4y prime plus 5y equals 4e raised to 3t, given y of 0 equals 2 and y prime of 0 equals 7, using Laplace transform. We will take the Laplace transform for each side of the equation. Then we are going to take Laplace transform for each of the terms of the left side. So we have like this. Now let us evaluate Laplace transform of y double prime and Laplace transform of y prime. We're going to use the two formulas here. So the resulting equation is like this. S squared times L of y minus s times y of 0 minus y prime of 0 minus 4 times the quantity s times L of y minus y of 0 plus 5 of L of y equals the right side, and we will just copy here. Next thing to do, we're going to substitute the corresponding values of y of 0, and that is 2, also for y prime of 0, which is equal to 7. The equation here becomes like this. We multiply this 4 inside the grouping symbol. Let us combine this negative 7 and 8. Later, it becomes positive 1. Let us put all those terms with L of y values together. So the resulting equation becomes like this. Next is, we're going to factor out this L of y variable from the three terms. So we have now this s squared minus 4s plus 5 multiplied by L of y. Then we copy this negative 2s plus 1 equals, for the right side, we put the constant 4 in front of the Laplace transform. And the next step is, we're going to evaluate the right side. 4 times L of e raised to 3t now becomes 4 over s minus 3. Next thing to do, this negative 2s plus 1, we will transpose to the right. Then let us combine the right side into a single fraction. This 2s minus 1, considering our s minus 3 denominator, we're going to multiply this by s minus 3 over s minus 3. When we combine our right-hand values, it becomes like this. 4 plus the quantity 2s minus 1 times s minus 3 all over s minus 3. Next is, we want to isolate the L of y in the left side. So let us divide this equation by the coefficient of L of y. We divide this by this s squared minus 4s plus 5. The resulting equation will be like this. When we solve for y, let us take the Laplace inverse of both sides of the equation. Therefore, y is equal to Laplace inverse of this fraction. Now, let us solve this by partial fractions. This is now equal to a over s minus 3 plus bs plus c all over s squared minus 4s plus 5. Let us solve now for the values a, b, and c respectively. Now let us multiply by LCD. We understand that the LCD here is the denominator of the fraction in the left side. Multiplying now, we have this new equation. Now let us solve for a. Look here at the second product with variables b and c. There is a factor with s minus 3. To eliminate this b and c, let us set s to be equal to 3. Meaning, all the s we will change by 3, then we will get the value of a equals 2. Next, let us expand this equation and group the terms respectively, which means the left side becomes 2s squared minus 7s plus 7 equals the quantity a plus b multiplied by s squared plus the quantity negative 4a minus 3b plus c multiplied by s plus the quantity 5a minus 3c. Next thing here is to equate coefficients for s squared. In here, the coefficient is 2, so we write number 2 here, and on the right side, we have this a plus b. A while ago, we have the value for a already, so let us substitute the value of a. It becomes 2 plus b equals 2. When we solve for b, it is equal to 0. Next, let us equate the constant terms. In here, the constant is 7. We write it here, equals, on the right side, it is 5a minus 3c. Again, we substitute the value of a in here. So we have this 7 equals 5 times 2 minus 3c. We get the product as 10. Then let us solve for c. The value will be positive 1. Let us substitute the values of a, b, and c in this partial fraction. So we have 2 over s minus 3 plus 0s plus 1 all over s squared minus 4s plus 5. Cancelling the 0 here, it becomes 1. Let us write again our equation a while ago, but this time we will use the equivalent partial fractions. Then we will show that we are going to take Laplace inverse of each of our fractions. We simplify further by putting this constant 2 in front of the Laplace inverse. And then let us now apply our formula for Laplace inverse. For the first Laplace inverse here, we have the immediate formula. For the second Laplace inverse, we need to do completing the square. For the denominator of the second Laplace inverse, we can split the number 5 into 4 plus 1. Then we group the trinomial s squared minus 4s plus 4. So we have this s minus 2 power 2. Then we just write plus 1. In the first Laplace inverse, we will now simplify it into 2 times e raised to 3t. For this second Laplace inverse, remember the shifting property, which means the value of this Laplace inverse is e raised to 2t times sine t. Meanwhile, I'm going to pin the video for shifting property of inverse Laplace transform in the description below. And this is now the final answer.